All right, today we're going to be learning some of the applications that involve exponential equations, and solving them is going to involve using logarithms. So, some vocabulary that we need to know for these problems. The principal. This is not Mr. Dolson. This is your initial deposit or value. Interest, in the situations we're going to be talking about, is going to be money earned through savings, like a savings account. Value is how much an item is worth, like a house, a car, jewelry. Depreciate, it means when something goes down in value. For these next couple, we're going to look at them in terms of how many times they happen a year. So if something happens annually, it occurs once a year. Like your birthday, Christmas, Easter, Halloween, first day of school. Semi-annually, well, it means it occurs twice a year. You've probably seen ads on TV for Victoria's Secret's semi-annual sale, JCPenney's semi-annual sale. Quarterly. How many quarters are in a dollar? Just like that, there's 4 quarters in a year. So that means it occurs 4 times a year. Monthly occurs 12 times a year. And daily occurs 365 times a year. If we want it to be more exact, we could say 365.25 times, but that'll give us a good enough approximation. And then continuously means constantly occurring, non-stop. All right, so we're going to look at 3 different formulas, and yes, you need to memorize them. The first is our appreciation-depreciation formula. The A value stands for, the A stands for the initial value, or initial amount. R is your rate. We need to rewrite it as a decimal. It's going to give us it in percent. T is going to be time in years, typically. What's time? V sub t is our final value. In our equation, we have a plus or minus. We're going to use plus when the value goes up, and minus when the value goes down. All right, so our first example. A car was purchased for $90,000 in 1995. If the value of the car depreciates by 5% every year, what will it be worth in the year 2020? So our starting value, A, our initial value, the car is initially worth $90,000. Our rate is 5%, which we'll put in as 0.05. Our final value is what we're looking for. And our time, how much time goes by from 1995 to 2020? That's 25 years. So let's plug it in. V equals 90,000 times 1. Now, should we use a plus or a minus? The value of the car is depreciating, which means it's going down in value. So minus 0.05. to the 25th power. Since there's no variables on the right-hand side, it's all numbers, we can just type it in our calculator. And you should get 24,965, and then we're going to round to 2 decimal places because we're talking about money. So 06, and then don't forget to include your units, which in this case is a dollar sign. All right, let's look at the next one. A house was purchased for $175,000. After 20 years, it is now worth $250,000. At what rate was the value of the house increasing? So our initial value is $175,000. Our final value is $250,000. Our time is 20, and our R is what we're looking for. So let's plug them in. 250,000 equals 175,000 times 1. The house increased, so plus R to the 25th power. So now we've got to solve this. We need to try and get R by itself. So in order to get this part of the equation by itself, I'm going to divide both sides by 175,000. And if I simplify that to a fraction, I get 10 over 7 equals 1 plus R to the 25th power. Then, in order to get rid of the 25th power, I'm going to have to do the 25th root on both sides. That'll leave me with 1 plus R on the right. Then we need to type the 25th root of 10/7 in our calculator. So we're going to do 25 math, then go down to number 5 where it's got the x for the root of parentheses. Actually, we can do alpha y equals enter of 10 over 7. So we get 60 over 71 over 59.85. Then we're going to subtract 1. So our rate equals, I'm going to change it to a decimal, 0.0143, which as a percentage would be 1.43%. To go from decimal to percent, you're going to multiply by 100. So let's look at our next equation, our next formula. Our next formula is for compounding interest. P stands for our principal, which if you remember from the vocabulary is our initial deposit. R is still our rate. We're going to do it as a decimal. T is time in years. N is the number of compounds. And uppercase A is the final amount. So if you just deposit $1,000, that's our principal. It pays 8% annual interest, so our rate is 0.08. Find the balance after 10 years, that's our time, if the interest is compounded semi-annually. So N, how many compounds would in a year is semi-annually? It's 2, because if you look back, we said semi-annually occurs twice a year. So let's plug this in. Our final amount's going to equal 1,000 times 1 plus 0.08 over 2 to the 2 times 10 power. Since there's no variables on the right-hand side, we can just type it straight in our calculator. So our final amount will be $2,191.12. Oop, too far. All right, our next one. You have an account that pays 4.5% annual interest, so our rate would be 0.045. The interest is compounded monthly, so N is 12. How long, so we're looking for time, will it take for your investment to double? So we don't know what our principal is or what our A is, or our final amount is. And we can't have 3 variables in one equation and solve it. So here's what we know right now. A has to equal P, I'll just put them in for a second, times 1 plus 0.045 over 12 to the 12t power. Now, you can pick any number you want for A and for P as long as A is double what P is. Now, I'm going to take the easy way out. I'm going to pretend that I'm depositing $1. If I am depositing $1, then we're looking for when it is changed to $2. Okay? 1 times anything is just itself, so I don't even need to worry about having that out front and dividing by it. So we need to eventually rewrite this so that we can figure out what t is. So I'm going to start by simplifying these parentheses. And this comes out to 1.00375. If this decimal kept on going forever, I might round and simplify it a little bit, but since it ends at the 5, it's only 5 decimal places, I'm going to write the whole thing. Then to the 12t power. Now, can we make these bases match? No, so we need to rewrite it in log form. It's going to be log of 1.00375 of 2 equals 12t. And then to find the time, I'm going to divide both sides by 12. On my calculator, I can type this in. To get the log with the base, I'm going to go math and go up to log base. The base is 1.00375. We're taking the log of 2, and then we're going to divide that answer by 12. Make sure the divide by 2 is outside your parentheses. And that gives us 15.432. So time equals 15.432, and we're measuring time in years. Make sure you're including your units. So if you're trying to find a rate, you have to use roots, rates, and roots. If you're trying to find time, you have to use logs because it's going to take a long time because it's a lot of work. Ha ha ha. All right, on to continuously compounded interest. P still stands for principal. E is Euler's number. You don't have to memorize the number. You just have to know its second natural log on your calculator. R is still our rate as a decimal. T is still time. A is our final amount. The thing that is different for this equation, and the reason we have a different equation, is because we are compounded continuously. So after compounded, if it says continuously, you use this equation. After the word compounded in the problem, if it says anything else, you're using this equation. All right, so if you deposit $1,200, so P is 1,200, into an account that pays 5%, R equals 0.05. After 10 years, so T is 10. What is the balance? So A, if the interest is compounded continuously. So A equals 1,200 E to the 0.05 times 10 power. Let's look at what this looks like on your calculator. 1,200, second natural log will pull up the E to the 0.05 times 10 power. So we'll have $1,978.47. Right. 47 cents. Yeah. All right, last example. If you want your investment to grow from $50 to $500 in account with an interest compounding continuously in 20 years, what would be the interest rate on that? What would the interest rate on that account need to be? So, final amount 500, initial amount 50, rate is what we're trying to find, and our time is 20. So 500 equals 50, E to the 20 R. Divide both sides by 50. Ten equals E to the 20 R. This time, because the R is in the exponent, we can't use roots. We have to rewrite it using natural log. So the natural log of 10 will equal 20 to the 20R. So divide by 20, divide by 20. R equals natural log of 10 divided by 20, 0.1151, which means we need an 11.51% interest rate. That's all for today. Make sure you memorize your formulas. See you in class.